And another thing is, with JavaScript, it's platform neutral, it is operating system neutral. Okay, so you just write it once and it will run on any machine, right? Okay, so when it comes to building a botnet, there are two sections to it. One is you have to first recruit the zombies, right? And the second one is you have to make sure that your script is running on the zombies machine for as long as possible, right? So the first one is reaching out to victims. So how do you actually get your JavaScript running on your machines? So there are a lot of different ways by which you can do this. One is email spam. You just have to send links to people and get them to click on it. The other one is trending topics on Twitter. I don't know how many people actually use Twitter, but if you just send a tweet which has a trending topics name into that, there are lots of people who will actually click on it, right? And in Twitter, it's all shortened URLs. Nobody actually knows which link they're going to, right? And the other one is persistent accesses on popular websites, right? So that's one way where you can execute code in people's browser. Search engine poisoning and compromised websites. If you take over a website, you could probably put your HTML page on that, right? You don't have to put in even PHP. And anybody who comes to the website is going to execute code which is there in this HTML page. I don't have, Rohit just told me that I've got very little time, so I'm going to just run through this. Okay, so I told you one is you get people to visit the page, and the second thing is you have to make sure that your page is open on the victim's browser for as long as possible, right? So if your page is only going to be open for 5 minutes, it doesn't make much sense, right? So the way in which you extend the lifetime of your page is by using a combination of clickjacking and tab mapping, right? I'll just show you a quick demo of it instead of talking about it. Let me close all these other tabs. Alright, so this is a simple page which has actually nothing on it, right? So let's imagine this is the page which the victims would actually come to initially, right? And I'm saying you click on this link to view this or something like that. So they click on it, and when they click on it, it actually opens a different tab, and it loads a different site onto the tab, right? Okay, now this is Yahoo, and usually folks have 8 or 9 tabs open on their browsers all the time, and they don't really know which tab they're using. So the other tabs are just open. They don't even bother closing them. Now that's one thing. The fact that we've opened a new tab and we have got the user to move on to a different tab, is one trick by which you can make sure that the guy does not come back and close the original tab, right? The other thing is now we are going to basically camouflage our tab. So now if you look at the open tabs, you can see that the tab called is Google, right? I actually had no Google page open. I just closed all the tabs that were there, right? So if you go to this page, and it's got the Google Fair icon. So if you go to this page, it says Google, right? I'll do a search here, and it shows me the results as well. Right? You see anything strange in this page? Right, the URL is still the same URL, right? So you're still on my page at localhost, right? But if you look at the file icon, if you look at the title, if you look at the page, you actually think you're on Google, right? So this is another way. So even if this guy comes back with his tab, you can still keep him on the same page, right? So by this way, you could basically extend the lifetime of your JavaScript on a person's browser. Okay, 5-10 minutes, right? Okay, so once you've extended the lifetime, so now you are in the victim's browser, you're able to execute JavaScript for a long time. So what can you actually do, right? Because JavaScript has very limited privileges. So I'll talk about 3 things that can actually be done. One is distributed denial of service attacks, email spam, and distributed password tracking, right? Distributed password tracking is going to be really interesting. Okay, first is DDoS attacks. Now normally you don't think you can do a DDoS attack using JavaScript, even the thought seems pretty lame. But with HTML5 you actually can, it actually makes it possible. I told you that using HTML5 you can create cross-origin requests, right? Now I didn't talk about the number of cross-origin requests you can actually generate. Now I did some testing on my laptop, and I found that I was able to generate 10,000 cross-origin requests in 1 minute, right? So a JavaScript running on my machine in just one tab can create 10,000 HTTP requests in 1 minute. So imagine, my JavaScript is running on 600 machines. So the number of requests it can generate is 100,000 requests per second, right? And if it's going to run on 6,000 nodes, it's probably 1 million HTTP requests per second. That's the kind of HTTP packets we're generating using pure JavaScript. And I just have to get 6,000 people to visit my site, and I can send 1 million packets to any website that I want to send, right? And if the URL to which I'm sending these requests is going to be a process-intensive URL, which is going to search their entire database probably, even with 600 nodes, I can take their site down, right? And most websites, they're pretty slow even when a few people are using it. So with 1 million requests per second for a process-intensive URL, it's going to be DOS. It's going to be DDoS. Right, so that was DDoS, and then the other one is email spam. And email spam is something, again, which you cannot associate with something which can be done from the browser, right? Because you would have to send, you would have to talk to port 25, where your SMTP is running. But we actually have web-based interfaces to these SMTP ports, which is your feedback forms. A lot of different websites actually have feedback forms. So when you enter your email ID, you enter the title, you enter your comments, and then you click submit. What it actually does is, it talks to the main server of the company, and it actually sends a SMTP packet. Now, a lot of these forms are designed insecurely, in the sense the from address and to address are both included in the HTML page, right? So when you actually hit submit, you will see a request which is being sent, which contains the from address, the to address, the title, and the body of the SMTP request. So it is just one HTTP request which is used to send an SMTP request. So using cross-origin request, you can send this HTTP request with any value set for the from mail ID and any value set for the to mail ID, and now you're basically sending spam emails using some other company's mail server using HTTP and using pure JavaScript, right? Alright, so the last part is password cracking, distributed password cracking using JavaScript. This is my favorite part. When you talk about password cracking, you're always talking performance. I have to write it in C. Even password crackers written in, I've not seen any password crackers written even in Python, right? Because folks usually write it in C, and even C is not good enough. They write parts of this code in assembly, because they want it to be fast. But what I've done is I've written a password cracker in JavaScript, which is very, very slow when compared to native code. It was slow a few years back, but now JavaScript engines, thanks to Chrome, right, are very, very fast, right? People have been, the speed of JavaScript engines is increasing at a faster rate than the speed of your operating system. The speed of your hardware, right? So I'll give you a bit of a comparison. Password cracking in JavaScript is probably about 100 times slower than password cracking in native code, right? It's just 100 times slower. So that means if you have JavaScript running on 100 machines, it's equivalent to running the same password cracking job in one native machine. In native code on one machine. And if you're going to run it on 1,000 machines, which is very easy, when you're looking at JavaScript, it's equivalent to running the native code on 10 machines, right? So if you have a botnet, JavaScript botnet with say 10,000 machines, probably, it's probably equivalent to having 100 machines doing password cracking in native code, right? And 100 machines in native code is a huge, huge number. And the kind of figure that I got was, the best I got was 100,000 MD5 hashes per second using JavaScript, right? So that's really fast. So what I've done is, I've written a tool called the Router, right? So which basically does this password cracking in a distributed manner. So the whole thing with JavaScript password cracking is distribution. If you only have 2 nodes cracking your password, it's completely useless, right? The fact with JavaScript is you can execute it in thousands of machines, and that's what you have to basically make use of. So this tool is hosted on my site, and it can crack MD5 and SHA hashes, right? So I'll just show you a quick demo of that. Alright, so this is Robin. So what I'll do is I'll create an MD5 hash. And let's say I'll add a salt to it, right? So this is the value of the hash. And this is the value of the salt, right? And it's an MD5 hash. It's all uppercase. I know it's all uppercase. So what I'll do is I'll remove the other character sets just to make it faster, for the demo. But in the actual case, you wouldn't know which character sets are there, so you would want to keep the entire thing. Alright, so I'm submitting this hash. Okay, so once I submit it tells me what's the hash ID, and then it gives me a worker URL, right? So this is the URL that you will have to send to all the workers, right? So what I'll do is I'll run a worker on my machine itself. Okay, so I'll say start. Now I've designed it in such a way to prevent abuse. But when an attacker is actually doing it, you wouldn't have a start button, right? It will just start automatically. Okay. All right. So you can see the worker has started. It's running a background JavaScript thread in my browser, and it's fetching work. So what basically Ram does is it divides the entire cracking process into smaller sections called as slots, right? And each worker picks one slot at a time, and it works on it. And when it's done, it basically puts the results back on the server. So currently it's cracking slot number 2, and the speed at which it's doing it is it's around 63,000 hashes per second. 63,075 hashes per second. If I don't have VMware and other things running on my browser, it will probably be much faster. And if I run it on Opera, I'll probably get 100,000 hashes per second. Opera was the fastest browser that I was able to see so far. So, okay, so this is the actual attacker's page. I'm sorry, this is the master's page, right? So this is where I submitted the hash. So you can actually see the stats of the cracking process. So currently it says slot 1 is completed, and the average cracking speed is 16,666 hashes per second. If this URL has been sent to some 1,000 workers probably, and if all of them are cracking, it will show me the combined speed. What's the combined speed at which my hash is being cracked, right? Right, so this is going on. I guess it will probably crack it around slot number 30. I guess so that means it will take another minute or 2 max, right? So so when this is doing the work for us, I could probably answer any questions for you if you have. No? Right.
So this one, does this show up the memory utilization of the tab?
In fact, it does, but not by much. Yeah. So on my machine, it's actually silent.
Can you check on what the tab utilization?
Yeah, we can do that. Now, I don't know which tab it is. Whichever is using the most memory is probably that tab.
Open the tab utilizations also.
From Pro?
Shift escape.
Okay. Okay, I guess it's. Okay, this is worker, right? Yeah, this is the worker. No, CPU is 25, right? So that's intensive, but memory is actually pretty low compared to the other types. But the whole thing is, as a user, you don't feel anything, right? See, it's running in the background. It's cracking hashes at around 60,000 hashes per second. But my UI is completely responsive, right?
Till the time that tab is open, right?
Till the time the tab is open, right? And to keep the tab open for a long time, I showed a couple of tricks. And in an actual case, the victim wouldn't be seeing these kind of fancy logos, It'll just be all happening in the background. Right, slot 13, I guess probably yes, slot 13 or 14, I guess it should crack it. Let's see. Yeah, so it's cracked this hash slot number 14. So on the master's page, you can actually see that it's been cracked at slot number 13, and this is the clear text value of the hash that you submitted, right? So if you're going to try this out, you have to be a little patient because it polls the server once a minute, right? So even if the hash is cracked on the worker, it'll still take a minute to show up here. It depends on when it's actually polling. So at this time it polled immediately, so I was able to see this. The other thing is, once you submit the hash, you have to actually keep this tab open. The master has to keep this tab open because he is the one who's actually managing the whole cracking process. So the moment you close this, the job is removed from the server, right? So that was it. If there are no questions, then thanks a lot for sitting through the session. I hope I was not too fast. You were able to at least understand a few things, and I hope you found the demos very interesting, right? So thanks everybody.